Database engines, sometimes called storage engines, sometimes called embedded databases, are software libraries that database management software uses to do low-level storing of the data on disk, or do CRUD, like create, update, delete. Some even do ACID transaction, that level of stuff, right? In this video, I want to go through a few popular database engines and explain the difference between them. And finally, I want to spin up the database and change them. So let's just go through the agenda here, talk through the things that we're going to do in this video, this tutorial, right? Informational course, whatever you want to call it. And as I talk through this agenda, you're going to start seeing time codes where you can jump to the interesting part of the video. You don't have to watch through the whole video to get to the interesting part, obviously. So let's go through the agenda. So first of all, what I'm going to do is define what a database engine is. We know what a database is. What the heck is a database engine? Why are we keep inventing stuff, right? So we're going to talk about that and why do we split a database from its engine? Very critical thing. We're going to talk about one of the most oldest, I don't think oldest is the word, my ISAM, right? So this storage engine is very popular back in the days, right? And we're going to talk about it a little bit. Again, I'm going to talk about ARIA, another storage engine very similar to my ISAM, right? We're going to talk about why do we have so many. There is technical reason, and there is also political reasons why we have this stuff. Okay, I'm going to talk about AnyDB, our first transactional engine that supports transaction. ExtraDB, similar to AnyDB. I'm going to talk about LevelDB from Google, right? And then we're going to talk about RocksDB, right, from Facebook. And we're going to talk about SQLite. SQLite, it's a database engine, but it's a standalone database. It's called embedded database almost, right? Then we're going to talk about BrickleyDB. Finally, we're going to do a demo where we're going to spin up a MySQL database, because one of these databases that it can change its underlying engine, which is amazing. That's why MySQL is the most forked database. You have a lot of databases that have forked MySQL because of this flexibility that you can change engines. How awesome is that? Okay, you can have a table with the AnyDB and another table with MyASM and another table recently even with RocksDB, right? So cool stuff. So if you're interested to know all of that stuff, stay tuned. Database engine. So here's the thing. So a database engine is nothing but a library that take care of the disk storage and the CRUD operations, like create and update and delete on the actual disk, right? Because guess what? When you do inserts into a table, values 1, 2, 3, well, what happens here is there are a lot of layers, and the lowest layer is we're gonna take your data and flush it to disk, right? Whether this is SSD or just a normal hard drive, right? Spinning wheel, right? There is a library that does that. Most of the databases has always merged this concept of a database into one monolith thing, right? But recently, this has started being broken into, okay, let me break these libraries into two parts, right? The actual work to store on the disk versus the actual work to do, for example, client server. That's different, right? I want this to be separated from this, so I can. It's a classic reusability software, right? This database engine can be as simple as just a key value store. Really, is just example a LevelDB, right? So I can put a key, there's a value, store to disk. That's it, right? It could be as rich as complex to support full ACID transaction. And we talked about ACID, guys. I'm going to reference it here. Atomicity, consistency, isolation, and durability, right? And supports transactions, supports foreign keys. All these functionality could be moved to the database engine. And that's could be really powerful for people who want to create a new databases, right? So it's like, let me just use this engine. I don't want to write my own engine, right? So yeah, a database could vary. Could be as simple as this. It could be as complex as have all these features. So a DBMS can use the database engine and build features on top of it, right? You might say, Hussein, well, if I thought the database is just storing stuff on disk, right? That's its job. Well, you're wrong, because databases support so many other features, and if you and I don't use it, enterprises use it, right? So like server replication, right? I wanna do a master follower setup where I have a master database or a leader database, and I want this follower node to copy its data. That has nothing to do with storage, right? This is a feature of the database. So you want to build this at the DBMS level, not at this database engine level, right? So isolation, some databases do very high level isolation at the database level, right? At the database software level. Stored procedures, foreign keys, so many things, features that the database can support, right? But it's independent of the engine storage stuff, right? So if you want to write a new database, you don't have to start from scratch. Just pick up an engine, pick up one of those engines that we're going to talk about, and then write your own database on top. And you can design your database to fit a single good use case that maybe the general purpose databases out there do not fit your use case, right? So you can start thinking about it. That's why we start to see a lot of databases software being created, right? Because there are specific use cases, and to be optimal in this day and age where latency really matter, where performance really matter, well, I'm gonna create my own database, and I am defining my workload so that it is, for example, it's a very high insert workload, but I barely read from my database, right? I don't know. This could be like a cold storage kind of a thing. Like I'm storing logs. Just let me store my logs, and I don't really care about reading. So that's one use case. Another use case could be, hey, I'm barely writing to this thing, but I'm reading a lot. So make read very fast. I don't care if you're gonna sacrifice writes. Okay, so you can play with this stuff, right? Sometimes referred to as a storage engine or embedded database, as we talked, right? Embedded database means like you can take it as it is and run it on your software, you can run it on your laptop immediately, directly. There is no client and server connection, right? It's a single library that you import in your code, and once you spin up your software, it just exists, right? Very powerful stuff. So some DBMSs gives you the flexibility to switch engines, just like MySQL, MariaDB, or Persona, another fork of MySQL. I couldn't find another database that allows you to switch engines except MySQL, but I might be wrong there. So correct me if I'm wrong. Some DBMSs, database management systems, that is, comes with a built-in engine that you cannot change. Postgres is an example here, right? You cannot change the engine of Postgres just to be something else. It's always B3, I believe. Okay, and that's it. You're stuck with B3s, right? So maybe that's a good thing. Maybe that's a bad thing, right? Right? And I'm trying to remember. Uber switched from. I'm not sure where they switched from. They switched either from Postgres to MySQL or from MySQL to Postgres. I need to confirm this information, right? They switched for a reason. I think that was part of the reason. So yeah, I just confirmed. I'm gonna link the article below. So they switched from Postgres to MySQL, right? I don't know the reasons, but probably one of the attractive reasons for MySQL is the ability to switch engines, the underlying engine. You're not stuck to one engine. You can create a table with this engine, MyISM, and then create another table with another completely different engine that does completely different things. So that's kind of attractive. I'm not saying that's the only reason. So I'm going to reference the article below. So they actually switched from Postgres to MySQL, right? All right. So that's another attractive thing. Let's start with the first one, MyISM. Okay, sometimes I'm gonna butcher the name, so I'm gonna say MyISM, right? But you know what I'm talking about. So it stands for Indexed Sequential Access Method, and yes, it says indexed because everything is indexed, right? And that means, right, every index you create points directly to the row. right? And that could be advantageous and sometimes bad. So we're going to talk through that, right? So it's a B tree, and I'm going to make a specific video about B trees and LSM trees, right? Let's not focus more about that. But a B tree is a computer science, architecture, computer sciencey stuff, right? That allows you to store data on disk, right? So you can search through them very fast, right? A lot of people don't know what B stands for. That's what the Wikipedia article says, at least. I call BS on that. I think it's just balanced tree. Why do we keep complicating things? Just it's obviously it's not binary tree, right? Because B tree is not really just two nodes. You can have multiple nodes. You can specify many nodes, right? But yeah, I would just say stands for balanced tree. Okay, you can call me out on that one. So yeah, the indexes point directly to the rows, right? So if you think about it, like there will be an index, and there's like there will be the data itself, that rows, right? And then the index will point directly to this place on disk offset where the row exists, right? So it's a very fast access to the location where stuff inserts are also fast, right? But it doesn't have really transactional support, right? So you cannot do ACID stuff on it, and we're gonna show that in the practical part of this video. So you cannot do transactions, guys. You're stuck. You cannot do like a banking stuff where you can debit one account and credit one account in one transaction. That's impossible. So that might be very dangerous to use. This app might ask them to. Maybe you can build it, the atomicity and in the database layer. That's possible, right? It's not hard, but it could be done. But MyASM on itself does not support transactions, right? So if you're planning to use transactions, you cannot use MyASM. It has been open source and owned by Oracle. So this thing had been flanking from different people, right? So I don't remember the first company that created it. It's a Swedish company, right? I think Sleepycat. I might be wrong there. And then Sun bought that thing, right? And then Oracle bought Sun and MySQL. And then Oracle owns all that stuff, MyASM and MySQL database. It owns pretty much AnnoDB, all that stuff, right? And we're going to talk about why people really hate that part and why people start forking. Once Oracle start owning this stuff, people start forking this thing and creating their own databases. So inserts are fast. Updates or deletes are problematic, and because they create fragments. So let's talk a little bit about that. So when you insert, you always insert to the end of the disk, and you know where the end of the file is. So that's fast, right? Because you always know where the end of the file is, and that's a very quick access to the end of the file. You know where it is, so you know you can throw stuff at the end. The problem is when you go back and you start updating existing rows, right? Or maybe deleting existing rows in the middle, right? So that's a problem, because the moment you start deleting and updating, you change the row size. And if you change the row size, the offsets change, and all these the indexes that point to that row, now the offsets change. You have to go and update all your indexes, and that's slow, man. So that's why updates and deletes, right, are very slow in MyASM, because you're updating that thing and you're changing the structure of your file, and guess what? Those poor indexes that point to this row index offset 700 is no longer 700, it's 705. So you have to go and change all that stuff, and that's expensive, right? So database crashes, corrupts table. I read this place, and a lot of people complain. Well, I faced this personally back when I owned my own MySQL. What is it called? The LAMP stack. I didn't own a LAMP stack. I owned a WAMP stack because of Windows. But it's the same thing, right? If the database, like in the middle of an inserts, the long inserts or updates, if it crashes, you have a corrupt table. You cannot access it unless you repair it, and that, right? And that is very problematic, right? If you corrupt your indexes, and you can see why MyASM tables can get corrupted, guys, like, because we just explained it. We have a lot of indexes that point directly to the location of the row on disk. That's bad, right? Because now you have to make sure the database have to update all these indexes, and that's bad. Because anything that gets out of sequence, well, you have to go and update that. There's a repair utility that repairs tables for you. And it supports table level locking. There is no row level locking. So if you want to prevent people from editing, you lock the whole table versus so that poor people, if they want to insert an irrelevant row, they cannot, right? Versus if you want to just really, you want to stop people from editing that particular row, right? You can't, right? That's the problem. AnnoDB supports row level locking. MyAsm doesn't. So that kind of slows writing down if you have concurrent users. MySQL, MariaDB, PersonaDB, all of these guys are MySQL forks. Well, MySQL is not a MySQL fork. They all support MyAsm, okay? Persona, MariaDB, right? Used to be the default engine for MySQL until I believe version 5.5, where those guys says, you know what, this is a mess, right? Let's support transactions, let's support row level locking, let's support all that foreign keys, all that beautiful stuff, right? We cannot just start building all these functionality on the database itself. Let's push it down to the storage database, right, as a database engine, so people can use this database engine to build their own databases, right? AnnoDB, the first, again, I might be wrong there, okay? It's not the first transaction. It's a transactional database storage engine, okay? So Aria and MyAsm was not transactional, so I cannot do transaction on those things. So I need something with transactions. What could that be? AnnoDB, meet AnnoDB. AnnoDB is a B plus tree, a little bit different than B tree, but essentially it's still balanced, right? The same idea. But here's the difference in AnnoDB versus MyAsm, okay? The indexes, right? There's always a primary key in AnnoDB versus MyAsm. You don't have to have a primary key, okay? That's the thing. MyAsm, everything is just an index, all right? And primary key in MyAsm happens to be unique index. In AnnoDB, on the other hand, you have to have a primary key. That's the first thing. If you don't create a primary key, AnnoDB will create one for you. That's sequential. Well, that's the first thing. The primary key itself, it has well-defined. Primary key points to the row itself, as we discussed. So I'm pointing directly to the row, right? And any index you create, guess what? It doesn't point directly to the row. It points to the primary key. That's powerful stuff right there, guys, right? So it's just like a primary key is like a one-to-one, right? That's powerful, right? So if you create an index, that index, the secondary index, doesn't point directly to the row. It doesn't point row offset 700. It doesn't say that. It says, oh, row 700. This index is actually pointing to the primary key, and the primary key points to the row. So you can immediately see there's multiple jumps and round trips to get to the row, right? But that could be also beneficial if you're only selecting your primary key and your secondary key. So you guys, the software engineer, database engineer, you really need to understand these things when you're querying your database. You don't do select star. That's the worst thing you ever do in a database, okay? If you do select star, you're hurting the database. You're just, it's like it has a life, man, and you have to appreciate it, man. You have to just, man, this thing, really understand how you deal with things in software, okay? It's very delicate, okay? You're dishonoring the database by doing select star, guys. Believe me, right? And if you're doing where clause, you better know what you're querying on, right? Too many indexes are too bad. Too little indexes are too bad. Know your stuff, right? And we can talk more about this, and I can make a whole video just about AnnoDB, right? I still don't understand so many things, right? But every time I understand a little bit thing, it feels really good. I appreciate the people who build these things more and more every day. So it replaces MyAsm, guys, right? You don't need this stuff anymore, MyAsm, right? A lot of people, I do not agree with that statement, right? Although I wrote it down, a lot of people says, nah, don't use MyAsm, always use AnnoDB. I need a reason. I don't like people saying just a blanket statement like that. You have to have a good reason, right? You have to have thought. You have to think about every statement you say, right? You can't just replace it. Well, there are features in MyAsm that InnoDB is bad at, okay? Okay, so you're gonna think about that stuff sometimes, right? It really depends on the use case. Sometimes your use case could be a MyAsm, as we said, right? I don't know. I'm reading a lot, but I'm not barely updating my tables, right? I don't need transactions, right? So think about that, right? Don't say just, this is old technology. No one uses it. It's like saying a statement like, oh, nobody uses Kerberos authentication. Oh, just throw it off the window. People built this thing in the 80s, yes, but those people are not dumb, okay? There's always a reason, guys. Think about it. It's a default for MySQL and MariaDB, okay? So that this becomes the default now. People use it. Doesn't mean it's the good choice. Guys, think about it, right? So default for MySQL and MariaDB and PersonaDB, I believe. I might be wrong there. ACID compliant transaction support all this good stuff. ACID, right? Atomicity, consistency, isolation, and durability. Support foreign keys. You know those guys, right? You know the foreign keys? What are foreign keys? Yeah. I can create a foreign key that links to that, and they kind of integrate together, right? Some people hate those foreign keys. I personally don't like to use them. I just, if I know white tables, I don't like to use this low level function. If I can handle it myself on the application. Again, right? That's my opinion. Table spaces support that's concept where a table space, right? This is, again, Oracle have this concept. I believe Postgres have this concept. MySQL has this concept. Hey, these tables are in this space. You're arranging your storage for some reason. I don't know, D drive or C drive. Probably a bad idea, but sure. Row level locking. Okay. Row level locking. That's a very good feature. I want to prevent people from editing that law. Yeah. No amendments, guys. All right, so I want to prevent people from editing the row, right? And because I'm doing something to it, like I'm doing like I don't know, I want to serialize some functionality, right? So it's like, hey, if you're editing that, if your function or application is trying to update that, you better wait, son. You cannot update that row unless I'm done. I'm gonna lift my exclusive lock, and then you can do your stuff. So that's powerful. MyAsm only supports table level locking. Okay. It has spatial operation, which MyAsm doesn't support. I might be wrong there. I think that functionality has been added. But here's the problem. It's owned by Oracle. So guess what Morty did? Morty created ExtraDB, which is a fork of AnnoDB. But here's the problem. It's owned by Oracle. So guess what Morty did? Morty created ExtraDB, which is a fork of AnnoDB. Same thing. You see the pattern, guys, right? This guy doesn't like Oracle. So he said, like, nope, I'm going to create ExtraDB, which is exactly like AnnoDB. And he started adding features to it. But, right? It's very simple. This B3, simple, similar, kind of ACID transaction, all that jazz. But guess what? It didn't work very well because Oracle is a huge company, and Morty is just one guy. So the features added to ExtraDB couldn't be kept up to date with the features that AnnoDB has. And there's a link here. I'm not making this up of my ass, right, guys? It's just I'm not pulling this up my ass. This is an actual link from MariaDB doc, right? So it wasn't kept up to date, so that's why. And then MariaDB 10.2 actually switched to AnnoDB from ExtraDB. So for a long time, the default was ExtraDB, and they switched it to AnnoDB, right? So now everything is AnnoDB. Okay, it's just sometimes at this point you're gonna bite the bullet and just run with it, guys. SystemDB, as we said, guys, the system tables on MariaDB are still using ARIA as of now. Okay, that's something I don't understand. Why all the system tables are non-transactional? Maybe there is a big reason, and I don't understand. I'm not an a big database engineer per se, but that's always like fascinated me. I noticed that pattern now with MySQL and MariaDB. They're using Aria, right, or using MyAsim as the internal storage. Well, there might be a reason for that. There's a good reason. So I might do some research there. SQLite. How did we go that far without talking about beautiful SQLite? Okay, created by Dwayne Johnson. Oh my God. Okay, The Rock created SQLite. Dwayne Richard Hip in 2000. He said, "Oh my God, can I just? Why I'm writing just when I write locally to disk? Why I'm writing directly to files using io.file.write? I want a database locally. Can I please have it, please?" So he created SQLite, and it was so popular. I think it's the very populate. What the hell is very populate? Look at this. Very popular embedded database for local data. Okay, is everywhere, guys. This local data, right? It's everywhere. SQLite, everybody's using it. It's in the browsers, it's in software, it's in operating systems by default. Okay, so this guy's created a beast of a database, of an embedded database. Okay, or a storage engine. Okay, it uses B3 by default, right? And this guy, Richard, tried to create LSM as an extension. I read, and I'm going to reference the article below. I read, okay, that he tried to implement LSM because LSMs just became popular all of a sudden, right? So he said, okay, I'll bite. Let me do it as an extension. So he did, and he did not see that much performance increase with SQLite because of the architecture that is built, right? It's just, you cannot build all of that stuff, right, in one way and then just decide to change it, right? The whole storage engine is just like, it's very intertwined, right? That's why MySQL did a smart way to separate these concerns. Like, so there's the database itself, and there's the database storage engine itself, and you can swizzle the engine to do anything else. So he didn't get that performance, but I think you can support it as an extension. You can try it if you want to. Okay, it's very Postgres-like, right? And it supports full ACID, right? And that's attractive. I still want to do ACID transaction, even locally, guys, right? Don't prevent me from doing that, even if it's locally. Sure, why not? But it only supports stable locking. It doesn't have raw level locking. Okay, and if you think about it, I don't know if you're gonna need raw level locking on local database. You don't have multiple users anyway, right? There's no multi-users. This is one single database, and better be one single user. Okay. For if you want to support multiple users, right? You have a client server DBMS like MySQL or Postgres or something else, right? That has ports that listen to a TCP connections and all that jazz, right? You cannot just have a local database that does all that jazz. Concurrent read and writes. Yes, it has concurrent read and concurrent write. You can write on parallel. How badass is this, guys? Okay, yeah. So he's using the operating system and he can write in parallel. Okay, that's amazing. So WebSQL, if you ever see WebSQL in your browser, if you go to console browser, you can see WebSQL. That's a SQLite, right? And I might do a video on WebSQL, right? Included in many operating systems by default. Windows included by default. I believe Linux have it by default. I might be wrong there. Aria. So there's this guy called Michael I'm gonna butcher his name. Widenius. Is Morty, I think they call him. Okay, so I think he's the creator of MySQL. He's the first one who created MySQL. So he created MyAsim. He created NODB, all that stuff, right? So he said the moment Oracle bought MySQL, not bought, but just owned Sun, which owned the open source, right? You would say that's open source, but it's influenced by Oracle. So he said, F it, I'm gonna create my own MyAsim version of MyAsim, right? A database engine. I'm gonna call it Aria. And guess what? Aria, first of all, let's jump back, a little back. He created a fork of MySQL and called MariaDB. And guess what? MariaDB is actually the name. Maria is his daughter name, so he called it on his daughter. And MySQL, guess what? That's how he also created MySQL. And My in MySQL is also his daughter. So, and her name is Mai. Okay, so Mai and Maria are both her daughters, his daughters, and they're both databases. Okay, so he created MariaDB, and he said, "Well, okay, I have MariaDB now. It's a almost fork of this," and he started creating his own features. Well, I can't use MyASM because it's owned by Oracle, right? Let me create my own MyASM, and he called it Aria. It's exactly like MyASM, exactly like we explained. There is one thing that he fixed. He made it crash safe. So if it crashes, it fixes itself, right? It fixes these indexes. So it's very, very similar to MyASM, okay? But it's not owned by Oracle anymore, right? And I think all the system tables in this is actually Aria, right? And MariaDB. They are not MyASM, okay? They are actually Aria. And it's designed specifically for MariaDB. As we said, it's a MySQL fork, okay? So Maria is the daughter of Mari, and Aria, okay? Why did he call it Aria? He wanted to call this also Maria, but that was confusing. So people said, okay, let's call it Aria then, okay? That's not the Game of Thrones character though. All right, Berkeley DB. So we're talking about the popular databases, and I'm sure I have left out a lot of databases, guys. This is from my research. These are the most popular. I might be left out any one of these databases. I apologize. Let me know in the comment section if I did. But Berkeley DB is one of these oldest databases that actually very popular. I don't think it's popular anymore, but it's worth mentioning, obviously. So Sleepy Cat developed it 1994. It's now owned by Oracle. You can see a theme, right? Oracle is like having a dominance on databases. Man, okay, it's just owning everything. So it has like influence on databases. So Facebook kind of broke that. Google started LevelDB, and Facebook broke that, and people ran with it. So it's just like the floodgates are open, right? And then this market share is just getting eaten from Oracle like there is no tomorrow, man. Man, RocksDB just, guys, Facebook, man. I love this company, man. The way they're doing his stuff, man. I don't work for Facebook, guys. I work for another company. I work for Esri. So geographic stuff, right? So, but yeah, we do a lot of databases as well. That's why I understand some of this stuff. Key value embedded database, right? So it's a key value store, and it's an embedded database. Supports ACID, support locks. I don't know what kind of locks here. I should have been very specific. I'm apologizing. Support replication, so it's always like a full-fledged database, right? That's badass. It used to be used in Bitcoin Core. The Bitcoin blockchain was using Berkeley DB at one point, and someone switched it to LevelDB. And I have a feeling that this will gonna change to RocksDB very soon. I might be wrong, but I don't know. Gut feeling tells me this will change. Anything that's still LevelDB is gonna just change to RocksDB, because RocksDB is just exactly like does everything that LevelDB does, plus a lot more. Okay. There's always an but there. There must be, if someone extended this and made it so much better, they must have given up something. Okay. I don't know what exactly, but I just have gut feeling that it is. It used in Memcache DB, not Memcache D, guys. That's a different database. That's an in-memory database. Memcache DB is a database. It's a different database, okay? Meet LevelDB. Google came in. They said, well, you know what? We don't like these B3's goofy stuff. We want something cooler, okay? So this has been written, LevelDB has been written by Jeff and Sanjay from Google in 2011, okay? Brilliant guys. And when they built this database, they had one goal in mind, right? They want to build a database engine, and they want it to be so fast and insert. And guess what? Why do we say so fast? Are you saying B3s are slow, Hussein, on inserts? Oh, well, yeah. And if you understand how B-tree works, you'll immediately know that every insert can trigger a rebalance to the tree. And when you re-trigger the balance, that could cascade into a slow performance up to, I think, big O of log of n, I think. Okay, whereas this guy is big O of 1 because there is no balancing in this thing. There's no tree to balance. There's a log structured merge LSM, and we're gonna make a video dedicated to that. I'm not gonna bother you guys with more details here. Okay, it doesn't have any transactions. Those guys are keeping it simple, right? So no transactions. This is the goal. We're building something for high insert and SSD, solid state drives. Okay, why solid state drives, guys? Let's think about it a little bit. Solid state drives and B-trees are a bad deal, guys, because every insert you do, right? It's not just going to the end of the file. Sometimes you have to go and update the tree to rebalance it, right? And when you rebalance the tree, you do an update, you move files around, and you touch existing bits on the disk to change it to something else. SSD hates that. Okay, you have limited number of lifetime for the bit on the disk and SSD. I don't know how much is that, but it's bad. They do not like that. Changing the bit on place is bad idea on SSD. Okay, yes, obviously we're running all on SSDs, and SSDs are getting better, but SSDs are fantastic for reads and fantastic for inserts. If there is an existing thing, you want me to add stuff, right? If there is a new blank disk, I want you to write to it, I can do this so fast. You want to read? I can do this so fast. You want to update? Okay, I can do that fast too, but you're gonna hurt me, man. You're gonna hurt me. You're gonna reduce my shelf life. Okay, because I can only change this stuff so much, after which this bit will get burned. And then if it get burned, okay, if that die, I'm gonna mark it as unusable. If that's marked unusable, I have to find another place for your bit, and that will degrade your life of the SSD drive. Sorry for the long rant there, but this is essentially, that's why their goal says, how do I build a storage engine that only inserts and never updates existing things? Okay, if I want to update, it's an insert. Okay, if you want to update, it's an insert. Well, you might say, Hussein, that kind of, isn't that just like losing disk space? Well, then you have to really think about what the heck are you doing. Okay, if you're deleting stuff a lot, inserting and deleting, probably not a good idea to use that model. Okay, if you're gonna fill up your disk space really well, right? And that's the LSM model is also good for historical reasons, because you know the history of what happened. Okay, nothing is ever deleted. Inspired by Google Bigtable, yeah, which I know nothing about. Okay, so I'm gonna leave it at that. Okay. I'm gonna leave it to the experts. If anyone who knows about Bigtable, please feel free to comment in the YouTube comments below to correct me or just add more information. Right? I might make a video about Bigtable in the future, where I will at that time, okay, will probably know about this thing. So why is it called LevelDB? It has levels, guys. Right? Always still recording good. It has levels, right? So when you insert, the first level is the mem table. That's the memory. And you might say, Hussein, what the hell are you talking about? Memory? Really? Database and memory? That's a bad deal, son. That's a bad deal. What if my database just crashed in the middle of writing to the memory table? Well, that's not durable. Those guys didn't say they are durable. But here's the thing. They do support write ahead logs, right? So wall. And when they write to the mem table, they also write to a log that commits to the disk immediately. So yes, mem table is there in memory, but they also write to disk in another place. And there's like a lot of another level. So the slower level and the slower level and the slower level until you reach all the levels, right? So young level and then levels 1 to 6, and then every level gets moved to another level when it's reached its size. Okay? So that's why it's called level DB. And Facebook, when they looked at this, they did not like this too much. So they built their own database that we're going to talk about in a minute. As files grow larger, levels will be merged and it will be flushed to disk. As we said, like always flushed, merge these two, flush it, okay? Used in Bitcoin Core. Bitcoin Core is actually using LevelDB. AutoCAD, some version of it using LevelDB internally. And Minecraft Pocket Edition, whatever it's called, also uses LevelDB, okay? RocksDB. Facebook looked at this. I forgot to mention the guy's name who actually built this stuff. He's amazing, smart guys, man. He's so genius, this guy who built this database. Okay, so he looked at this. He wanted to build their own database for Facebook-y stuff. They wanted to build their own stuff. And they looked at LevelDB and they loved it because of this SSD stuff, right? Because I want to insert all the time. Insert. I don't want to go back and update stuff because that reduces the life of the SSD disks. Okay, so what do? They forked this. A year from was created, 2012. They forked it and called it RocksDB, okay? And they built all these beautiful features. Guys, you have no idea how many features they added to this thing, right? I added to a list here. I'm going to reference this video below. I'm going to reference this link actually in the description below. So many features, guys. I cannot go possibly through all of them, okay? But here's just few of them, okay? They support transactions, okay? So now they are transactional, fully ACID. You can do ACID stuff. That's cool. A fast insert and ACID and not B-tree? Wow. This thing blew up out of proportion, guys. Facebook is doing a lot of innovation and innovative stuff. I'm gonna give it to them, really. They're doing a lot of innovative stuff. This is a great company. Okay. A lot of controversies, but you would think, but they build cool stuff, man. Transactional. So they made it transactional. So now the enterprise people got excited. Oh, transactional. I can build a server architecture, right? And a client server architecture on this thing, right? Let's do that. Well, everybody starts jumping on this ship, man. It has high performance because reads are fast, writes are fast. They changed these levels into something else, right? And they did a multi-threading compaction. These merges that we talked about, they did it as a multi-thread because LevelDB was only single thread. They used multi-threaded to write and read, right? So they started using threading to do that stuff. MyRocks. So here's the list of features. I'm gonna leave it below, guys. MyRocks for MySQL. So someone created a storage engine called MyRocks off RocksDB. They called MyRocks. And that's for MySQL, and you can do it in MariaDB and Persona. You can now do this MariaDB, Persona, MySQL. You can use MyRocks as a storage engine. You cannot use LevelDB as a storage engine for MySQL, but you can use RocksDB, and that tells you something. That tells you that this database rocks. Get it? Okay, that was silly. Mongo rocks. MongoDB look at it's like, what? I want to use this thing, man. Let's use it. So they switched to Mongo rocks to do this beautiful LSM stuff, large structure merge tree, and many more other people started using it. Right? And I'm gonna reference. I'm gonna show you a screenshot of. Oh, I took it from a YonaDB, I think. Where they show the difference between like LSM databases versus B-tree databases, right? Again, we're not saying something is worse than the other. There's always use cases, right, guys? Yeah, so don't get excited. RocksDB is just blowing up of proportion, but there's no free lunch. There must be, and I don't know what the cons and pros. I didn't do that deep level of research to find out that, right? And I don't understand how exactly it works to give you that answer yet. But think just high level, think about it, what you're doing, okay? And always keep in mind that nothing is perfect. and there's always use cases for everything. All right, database storage engine. So I took it from Yogabyte. I'm sorry, that's the name, right? I took this screenshot from Yogabyte. It's a beautiful picture, so I decided to use it and show you. This is the LSM log structure merge tree. This is the database that uses B trees, Oracle, TAF, Conda, right? SQL Server, IBM DB2, Postgres, MySQL, CouchDB base, MongoDB. You can use MariaDB. You can throw in Persona there if you want. You can throw in so many others here. Cassandra uses LSM, okay? Apache HBase uses LSM. Google Cloud Bigtable, InfluxDB. I don't know most of them, guys. Elasticsearch. A lot of people ask me to make a video about that, guys. Okay. And as I start talking, guys, write below what video, what database you want me to make next video about this, because this is just an overview of all of them, right? Because I want to pick one of them and just bite as hard as I can, right? That's what she said. Okay, I want to pick one database and just go as deep as possible. Okay, so RocksDB, I'm gonna make that deserve its own video. That thing deserve its own video. Yogabyte, again, I don't know them per se. I just found that from their while searching this stuff. I'm pretty sure it's a good database though. Couchbase, yes. CouchDB. I want to make a video about this guy because this puppy. This goes away. Couchbase, guys, right? Couchbase or CouchDB is one of those databases that I was hoping that it existed. It's an HTTP database, right? How coolish is this? An HTTP database. I was begging someone to build something like that. Okay, so I don't know if it's a good idea or not, but I wanted to, because every time if we build HTTP, we have to build this RESTful thing, Express or whatnot, or Flask or Firebase, and then on the back end, we start building a client that connects to an actual database. Why is my database not a web server, right? And CouchDB, I think, from what I read, is one of those beautiful databases that actually has HTTP protocol, right? And I'm very big fan of HTTP protocol. If you haven't noticed from my videos, I make a lot of videos on those stuff. Let's demo this thing. Okay, spin up a MySQL. This is what I'm gonna do. We're gonna spin up a MySQL Docker container. Okay, and we're gonna create a table with my ISIN, and we're gonna create another table with AnnoDB. Because you can do that. You can have two tables with different storage engines because MySQL is awesome. Okay. And you can connect to the database with JavaScript, right? That's what we're going to do. We're going to connect it with JavaScript. And I made a video just specific of that. I'm going to release it before this video goes out so you guys can see how you can connect from JavaScript, from Node.js to a MySQL. And you will be surprised how easy this thing is, right? Okay, once you know MySQL, by default, you know MariaDB. By default, you know Persona. See how transactions behave. Here's what we're gonna do. We're gonna see, since MyASM doesn't support transaction, I'm gonna show you how transactions behave in MyASM versus AnnoDB. So we're gonna do about that. Let's just jump into it. All right, guys. So the first thing we're gonna do is we're gonna spin up a MySQL Docker container. Because why I keep using Docker? Because your laptop is precious. You don't want to install garbage on top of your laptop or your machine if you want to test something and you're going to destroy it later. Use Docker if you want to test. Spin up a Docker container that you have your database on. If you're done, stop and remove that container. You're done. You don't have to uninstall and install and configure and you don't have to do all the garbage. That's why I use Docker a lot. And you need Docker, obviously, to do this tutorial. If you can do Docker run hello world successfully, whether you are on Windows or whether you're on Mac or whether you're on Linux, you're good to do this tutorial. So there's no intricacies of the actual platform. I just isolated that stuff. You have Docker, you can do this tutorial. Full stop. Okay. So once you do hello from Docker, you're good to go, guys. Right. So now what we're going to do is we're going to spin up a MySQL database. And how do we do that? It's very simple. Okay. To do a MySQL database, you can do this. Docker run -- name, and you give it a name, right? Always give your container a name. Okay. And I'm gonna call it MS, MySQL. Okay. I think this might exist, so I'm gonna call it MySQL 1. Because I'm not sure if it exists or not. And The next thing is I want to expose the port. The default port of MySQL is 3306. Okay, I am exposing 3306. Okay, so this is the internal port. That's the port that I want to expose my computer on. So that's what I connect to when I do Hussein Mac, which is my machine name, okay, or localhost. Next thing, the minimum thing we have to specify is a environment variable -e MySQL root password is called the most secure thing ever, password. My password is called password. Okay, I don't even add 1 2 3 because I'm that confident. Okay, so MySQL root password equal password, and then the final thing is this: you do MySQL, and that by default that will install the latest MySQL, which is I think version 8. Okay, and then yeah, if you're watching this 3 years from now from some reason and this doesn't work, just do this 8, and that will force version 8 to be installed. Okay, or version 5, or whatever version you want. Okay, let's go ahead and spin that up. It's called MS1. So, and let's just this will spin up and do all that jazz, listening to the port, exposing the port, all that jazz. And next thing, we're gonna go to another terminal. We're gonna connect to this container because we're gonna create a database, right? Because we don't have any of that jazz. We're gonna create a database. We're gonna create 2 tables. One is MyASM, one is ANO. Let's do this. Shell, new tab with profile. And here's the thing, okay? What we're gonna do is, we're gonna bash into the container. We're gonna enter the container command line prompt, and we're gonna run MySQL there because guess what? MySQL is existing on MySQL database, right? So here's what I'm gonna do. I don't want to install the client on my machine, all that goofy stuff. So docker execute -it interactive terminal. I want to connect to which container? It's called MS1, or you can call it anything you want. The moment you do that, I want to execute bash, because I want to bash into this thing. Bash it. I am there. I'm root now. And the next thing I want to do is I want to run MySQL. I want to actually run the MySQL command line, right? So you do MySQL -u, which user you want to connect to, root, worst idea ever, but sure, it's a tutorial. And then what's the password, -p, and make sure don't add a space after -p. Just immediately write your password, okay? -p password. Doesn't work otherwise. I have no idea why, okay? We're in Oracle owns this thing, okay? And then once we connect, guess what, guys? Well, let's create a database. Create database test, okay? Now I have a database called test. Let's create a table called, well, let's connect the database, use database test, right? I think it's just use test. Right, sorry. So use test, I'm now in the database. I'm going to create a table. I'm going to call it employees underscore MyASM. Yeah, it's just the name of that. But I want this to be in MyASM table. So I want to do ID, integer, primary key, and auto increment. Sure, why not? And when I do that, I'm going to give my employee a name, and let's do text. Okay. And then I want the engine to be MyASM. That's how you do it. That's how you set by default. If you don't specify that, I think the default engine will be AnoDB. I don't want that. I want the default engine to be MyASM. And I forgot the semicolon. And we have created a table. Okay. Another thing I want to show before we create the other tables, you can actually show all the engines that your database supports if you do show engines. And you can see all the database, all the engines. I support AnoDB. I support MyASM. I support this thing, merge MyASM. I don't know what's the difference really. It looks like it's a different thing. And if you install RocksDB, you can also get RocksDB here as part of the engine. Okay, you can get CSV if you want to. I don't know why would you do CSV. Actually, there is a good use case for CSV. If you're always exporting stuff to external table, you might just make the storage engine to a CSV and just take that CSV and put it in Excel. That's it, because it's essentially Excel, right? Excel can open CSV file. So there might be a use case for you to make your table storage engine to CSV. How cool design is this? Is part of the software architecture genius, right? That they built this as a separate layer. Okay, so they can just swizzle the engine underneath. Coolish stuff. So I'm gonna create another table, but I'm gonna call it AnoDB. Then we're gonna go there and create a transaction, right? AnoDB, okay? And I'm gonna call the table AnoDB, okay? I don't know what ANO stands for, guys. If someone knows, tell me. Okay. Now we have two tables, employees AnoDB and employees MyAsm. Okay. So now I can insert stuff if I want to, but I want to go to the actual, so if I do select star from employees MyAsm, there's nothing. Select star from employees AnoDB. So to us, this is just a table, right? You treat it exactly like just a client doesn't know if it's ISM or no. Well, the client can know if they want to, but the underlying storage is completely different based on how you store stuff. And we're gonna do another video where I can show performance between MyAsm and AnoDB. I insert like 1 million rows and 1 million rows in AnoDB and 1 million rows in MyAsm, 1 million rows in MyRocks, and compare the performance, what's faster, like 100,000 updates, 100,000 deletes, right? All that stuff. Okay, let's go to Visual Studio Code, write some code against this. How about that? All right, guys, so I'm here in Node.js and Visual Studio Code. Again, guys, I'm going to reference the video that we did, MySQL versus JavaScript, and how do you do that. I'm not going to go through details and how I did that because I already did that in details in that video. So go check it out if you want to, but I'm going to gloss over these ideas. So I'm going to use the MySQL promise library here, and I'm going to create a function called connect to MyAsm. This will insert a row. This essentially will insert a row, but in a transaction. So I'm not going to commit the transaction until I literally say commit, okay? And we're gonna go back to the terminal and see if my table, my row is there or not, okay? Despite I am in a transaction. So let's go and check that. So connect MyAsm, let's go ahead and call this function. And what it does is it do a try catch, connect to the database, and this is my machine name. You can do localhost as well, same thing exactly. Because some people, some of you guys say like you're having trouble using the host name for some reason. So you can use the local host if it's the same machine, okay? The port 3306 because I'm connected to that. The root is business password, root password, the database test. I'm connected to that. Next thing I'm going to do is I'm going to begin a transaction, okay? And anything in that thing, if I do a transaction, if I insert into my table, because employees insert, the transaction says the idea of a transaction is if I insert or do delete, none of those guys can see anything. None of other external clients can see my changes because of the isolation level, right? Ideas, guys, right? Dirty reads and all that stuff, non-committed reads, right? If I do that, nobody can see this thing unless I commit my changes. Even if I commit, there's a little bit of gray area there because other transaction can have an isolation level of read committed or read non-repeatable reads. If they do non-repeatable reads, even they are committed, they will not be able to see my changes because their changes essentially at the transactional level. But I made a video about ACID. If you're interested to do that, go watch that. I actually dive deep into more details about isolation and all that jazz. But let's go ahead and do a connection.query. And I'm going to execute this query. Insert into my, it's called employees. And that's the thing. This thing is this is lowercase, right? Sensitive. MySQL is case sensitive. So I have to do this, MyAsm, all right? And I want to insert the ID. We don't have to build ID, just name. And the values is, right? Values is nothing, and the name is Hussein, okay? So I'm gonna insert a user called Hussein here, okay? And then after I do that, I'm going to do await con.commit. I'm gonna commit my transaction here, okay? All right. Let's test this out, guys. I'm gonna put a breakpoint here on connecting to MyAsm, and I'm gonna run this thing. All right, run. and we're about to execute the query. So I'm gonna go ahead and execute it. And I just executed the query. Now I inserted Hussein to employees my ISIM. Let's go and see. I'm not gonna commit yet. So the breakpoint's right there, stuck, right? I didn't commit. So if I go to my ISIM, my table, and say select star from employees, my ISIM. What? How did that get in? Other clients are seeing my changes. And you know why, guys? Because my ISIM does not support transactions. Period. You cannot do begin transaction and you can change your stuff. The moment you start inserting, it's visible everywhere. You're out of luck, man. You cannot. That's it. The moment you do that, whether you like it or not, it's committed. Whether you committed or not, you cannot roll back. There's no roll back on this thing, okay? That's it. You inserted, you're done. Sorry. If you don't want it, do essentially go ahead and turn around and delete it, right? But that's essentially it. Because that's the my ISIM story, okay? So let's go ahead and do exactly the thing, but connect my AnnoDB. Okay, let's do my AnnoDB. And I'm exactly gonna use this guy. I'm gonna steal code from here. Because it's the same, if you think about it, it's like the same exact code, right? All right. So this is my function called connect AnnoDB, right? Again, I'm gonna put a breakpoint here, and I change this into AnnoDB, right? Because that's the table I'm gonna write into. I'm gonna put a breakpoint here. I am calling connect AnnoDB. How about we test this thing, guys? Let's see. Now, if I go, let's go here. Select star from employees AnnoDB. There is nothing, okay? So what I'm gonna do here is run. All right, I'm gonna begin the transaction. I'm gonna insert Hussein into AnnoDB table. I go here and I do select. Guess what? It's not there because I did not commit it despite me. Now, if I stop, let's do this, right? If I do const result rows schema equal con.query, and I do select star from employees AnnoDB, right? Right, we need to do a wait, obviously, guys, and then let's do it. So if I do this query and then give me the rows back, look at that. We have a row and there's Hussein. I did not commit, but within my transaction, I can see my own rows, okay? I can even print them, okay? I can see them. I can query them. I can query the changes I make. Guess what? I go back here, select star. It's an empty set, okay? Other clients cannot see my changes. But the moment I commit, I go back. Look at that. It's right there. Okay, guys? So that's essentially what transactions is. So my ISIM, you can change the engine. My ISIM doesn't support transactions. AnnoDB does, foreign keys, all that stuff. So this is just like a little bit a demo showing you the difference between AnnoDB and MySQL, and just the idea of you can change the underlying database engine and do coolish stuff with it, guys. All right, guys, hope you enjoyed this whole big videos about database engine. I'm gonna see you in the next one. Okay, what do you want to see next? Let me know, and we'll have discussion. Let's see what's your favorite database, guys. What do you like to use in your projects? Okay, you like MySQL because you can change the engine, or do you like the simplicity of just using Postgres and I don't really care? Let Postgres do the optimization for you. What do you like? Right? There is no wrong answers, guys. Right? And yeah, I'm gonna pick up one of those databases, start making videos about them. There is a lot of videos that I want to make, guys. Yeah, but I'm gonna keep making videos. Hope you enjoy the content. Let me know what you want to see next. I'm gonna see you in the next one. You guys stay awesome.